Welcome back to Follow the Compass North. Today, I'm going to be discussing heat transfer vectors. Now, this seems like a pretty in-the-dirt discussion, but it relates to one of our three main basic needs. And if you haven't seen those three main basic needs, go back and watch our survival needs episode. A recap would be health, personal protection, and sustenance. Today we're not talking about health and sustenance so much, but more about personal protection. Personal protection is making sure your body maintains 98.6, and that's going to be fighting the loss of heat or fighting gaining too much heat. And our body tends to do that naturally anyways through sweating and evaporation for cooling down, from shivering and increased metabolism for heating back up. However, we do need to be cognizant of the 4 different methods that we could see heat leaving our body so we can combat this ahead of time. Whether that's through shelter, fire, clothing, other equipment, it doesn't matter. As long as we understand the ways that we can lose and gain heat, we're able to get ahead of that through those use of that equipment. I left respiration down here because it is commonly talked about in many survival manuals as a form of losing heat, but if you break it down, it's really a factor of the evaporation of the excess moisture in your lungs and the convection, air currents, and conduction with that air current breathing out of your body. So respiration is a factor of these other 4. We'll start with the easiest one. Conduction is the direct heat transfer from touching piece to piece. This guy sitting here, he's touching this rock, which means that the slower molecules on the rock are being hit at an increased frequency from the molecules that are vibrating in his body. It transfers that physical vibration, and that physical heat will lower for him and raise for the rock. Everyday thing. Every time you reach into an oven and you pull out something that's hot and burn your hand, or if you pick up a snowball or a cold wrench in the snow and feel the heat leaving your body, both are examples of run-of-the-mill conduction. Evaporation is because your water on your skin, your sweat, is trying to turn into a gas. The higher heat that you are, the easier this happens. Of course, the boiling temperature for unimpeded water is 212 degrees. We're not quite reaching that, but because of the slow air current over the body and the leaving of that liquid to gaseous form, you see a drop in temperature, and that's evaporation. That's why whenever you get out of the shower and you're still cold and a breeze hits you, you cool off even faster. Evaporation makes up for about 30% of our daily heat loss, not considering wet clothing or wet shelter or rainy conditions. Convection and conduction together make up another 30% of that. Now, convection is a bit of a confusing topic because convection is the form of conducting the heat near you and radiating the heat near you and then having that air current flow. Now, that can be an air current, the Coriolis effect. That could be a water current. It could be material moving past your body in a way that it pulls heat away faster. We use this in active heating, active drying, active cooling for those who get overheated in the summer months down here in the south. Radiation's our last one, and I've thought on radiation for a while. How can I describe what radiation is? Well, radiation is the radiant heat coming off your body, not in a conduction, convection, evaporation form. And the best way for me to visualize this is to actually visualize it with a thermal camera. Now, a thermal camera will see that radiation coming off your body from a great distance away without actually having to have heat conducted all the way to that camera, without having to test the air currents of the convection or evaporation. You can see radiation from a lot further out because it comes off of you in a radiant form. Now, there are more extreme versions of radiation heat, such as the sun, or UV, or alpha and beta and gamma particles, which would be a form of radiant transfer of heat to or from a body. Hopefully not from, that means you're quite irradiated at that point. And being radiant isn't always a good thing. So those are some of the things you want to consider before heading out into a backpacking setting. Are you carrying the right equipment? Do you have the right clothing? Do you have an extra pair of clothing? Do you have an extra pair of socks to switch out? Do you have what you need based on the type of temperatures that you're going into? Now, we're going to get deeper and deeper into this. We're going to be doing some winter survival challenges this next December. We're going to be having a lot of fun with this, but I wanted to talk about the basics here today so I can refer back to this video and not have to cover heat transfer vectors or heat transfer techniques in the future. If you enjoyed today's content, check out some of our other videos. At this point, I think this is number 24. So our next one's going to be a waypoint video. Less instruction, more just checking in with our fans. So stop in, say hi with that one. And then we'll continue on making more and more of these instructional videos. So if you want to learn something specific, leave a comment below. If you have any questions, leave a comment below and we'll get back to you. If you like this, check out other videos, share, subscribe, like. Whatever you do that helps our channel is greatly appreciated. So thank you and have a great night.